Hello, I am PIrwin, and I'm going to present to you my final literature paper on the effectiveness of probeware in science. Here is my complete title: Probeware in Science Classes, a comprehensive review if probeware increases student understanding and enhances learning. The purpose of this literature review was to perform a comprehensive review of probeware in science, to determine if probeware increases understanding and enhances learning, and to see what research has been done comparing the use of probeware for collecting data during experimentation to using traditional old school methods. For the rationale, it is covered under two standards. The first for the International Society for Technology and Education, or ISTE, their standard number 4 for critical thinking, problem solving, and decision making. And the second was for the Association for Educational Communications and Technology, their standard number 3 for living environments. I proposed 3 research questions in this literature review. Number 1, when and how does probeware affect learning? Number 2, how should probeware be presented to promote understanding of a topic? And number 3, does probeware meaningfully alter the way material is presented to and processed by students? In the introduction, I covered the following. For the background information, the general term probeware is for lab interface units with microprocessors, probes, sensors, and software used to make various measurements in a variety of science laboratory experiments. The lab interface units collect the data in real time or download after the experiment has concluded. The probes and sensors have transducers to convert the physical quantity, things like temperature, pressure, pH, etc., into an electrical signal. The data collected can be viewed as raw data in a table or as plotted data on a graph. The graphing software can be analyzed to show the user the best fit, slope, etc. This picture is kind of showing you the various interface units that I have used over the years with Vernier and Texas Instruments. And these are the various labs I have conducted with my students over the years as well, showing you the different probes and sensors for temperature, pressure, pH, conductivity. Now I just kind of want to give you a view into what the students actually see when they are collecting the data here. This is the data typically viewed for the determination for determining the concentration of a solution using Beer's law, and you can see that the live data is viewing in the lower left corner. The raw data automatically collects into a table and it plots simultaneously onto a graph. You can also get a linear fit of a line, whether it be a curve or straight, but this one, I should say a best fit. This one actually is a straight line, so it'd be a linear fit, and you can see the slope, the intercept, and the correlation and the root mean square error on here. Those are nice for the students to see. We can also get statistics for the mean, the median, the standard deviation, and the minimum and maximum points. And we can also determine unknowns through interpolation. First, you would collect the unknown in a live reading, and then through the use of analyze and interpolation, you can actually match the interpolation line as close as you can to that live reading of the observance to determine the unknown concentration. So it's really nice, and the kids really get a lot out of seeing the relationships live as they're performing the lab, as opposed to later when they're putting it by hand onto paper. So in the results, 52 resources were screened in this literature review, including 38 peer-reviewed journal articles. Only 33 provided answers to the questions I posed, 23 of which were peer-reviewed journal articles. In answering question number 1, when and how does probeware affect learning, I found the following. I found research supporting that it does promote critical thinking and problem solving. The students were more engaged, better understanding of the STEM concepts. Students got to work at their own pace. It helps students build their skills in science literacy, and students prefer technology. I also found improvement of understanding, collect instantaneous data or time-consuming data. in a short amount of time. Conventional methods resulted in better understanding on how to construct a graph. PIrwin resulted in better comprehension of the graphical relationship between the independent and dependent variables and higher student achievement. And then finally, once again, seeming a little bit redundant, but you're going to see a lot of consistency here, that promoting understanding of science concepts and graphing skills. For number 2, how should probeware be presented to promote understanding of a topic? I found the following. The teacher should facilitate and mentor the students, providing structure and support. There's a need for careful instructional planning before implementing the technology into the curriculum. Gradual release in 3 phases, starting with teacher-directed activities to teacher and student collaborating, and then finally student-directed inquiry-based experiments. Found clear and precise learning objectives with clearly defined due dates, and traditional summative assessments were being requested by students. Also found staff development, collaboration, support provided before, during, and after the implementation of the technology to be beneficial. Teachers' knowledge of the concepts, their grasp on how to use the probeware, and their personal input to help the students draw relationships. Students' ability to make observations and predictions is dependent on the type of instruction they receive, and students work best with peers and groups. For number 3, I found this. A direct relationship between the use of probeware and increased student performance. Students are more motivated to learn, increased comprehension and retention as a result, promoting critical thinking and data processing, significant overall improvement in graphing skills and interpretation of concepts using probeware. Real-time data collection results in greater retention of the concepts being taught. Students can visually see these changes on live graphs produced by the probeware software. Misunderstandings are reduced. Students become independent thinkers using probeware. Students enjoy labs more, gather data more quickly, easily examine the relationships between variables being tested. Data is more accurate and measurements can be made that are impossible with manual instruments. And enhanced learning, deeper understanding of content, better interpretation of the data being graphed, increased patience, better problem-solving skills, more inquisition, better participation in groups, and improved communication of results. Students had a deeper level of processing for explanations, asking questions, self-evaluation, and suggestions for improvement or alternative design, and increases students' interest in science. Recognize the trends with the data being plotted, resulting in increased comprehension between relationships. Students were more engaged and became better critical thinkers and problem solvers. Increases the students' interest, but does not necessarily improve their understanding of fundamental concepts overall. So in the discussions, my main findings, summing up what I just pretty much covered, is that students had a better understanding of the concepts being taught and or tested. Students performed better on assessments as a result. Students had an increased comprehension of graphical relationships. Students were able to draw connections between the variables being tested. Students asked more questions and communicated their results better. For the relevance and limitations, since there was a lot of consistency between all them findings, even though Vernier had an independent research group, and that would somewhat appear to be biased because they're selling the equipment, the independent research group came up with the exact same results as everybody else, so I could rule out bias. And the people that would be the most interested in this would be educators considering adopting probeware technology. Obviously, the information of this supporting that it would increase the students' understanding and improve their assessments is definitely going to help them out. For the implications and conclusions, I found this, that there was not much research available comparing probeware to manual techniques. There were literally only a couple over the past couple of decades, which really surprised me. There was not much available concrete. By concrete, I mean more quantitative research showing statistically if students had improved graphing skills with scaling, plotting, best fit linear relationships, interpolation, or determination of statistics if they were doing this manually by hand on graph paper. In my opinion, data analysis involving critical thinking, analysis questions, and or problem solving is more important than the technique that the student uses from what I've seen over the past 22 years. And that answers to free response summative questions shows whether the student fully understands the material being tested and the relationship between the variables. And here are my references.